that's basically it. Hello everyone, it's December 25th. Well, I was just thinking about this. You can get inspired by someone and change your life and do things that you normally wouldn't do. And that person doesn't really have to be a role model, right? So you got inspired. It could be just one aspect of that person's life and then it inspires you. But you can disagree with other things. Yeah, but I was just thinking about it. Kind of funny, right? The two doesn't really have to align. I mean, if somebody is kind of a role model for you or you look up to that person, then yeah, you get inspired by that person. But I don't really think the other way around always hold true. It's okay. Like, we can disagree with people. People change, People change. You can get inspired when during the period of time when that person really is inspiring. But it can also be like after that period of time, you'll be like, you know what, I don't feel like that anymore. People grow, we grow, and that person grows as well. So it's all just normal. Jump game. Look at this, 14,000. Given integer nums, you're initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last, otherwise return false. So if I jump the maximum jump length, so if I jump 1, I can do 1, 2, 3. Gotcha. So basically it's a DP, just at each position we say if we can make it. Like this one we say yes. This one we can do 1, then it's a yes. And this one, it's a yes. So this one, it's a yes. 10 to the 4th, I mean, we don't want to go for every single one, right? And how would you say, well, I mean, so this one, if it's a false, right? This one is a false, right? I can now go. And in here, I can go one step. Or maybe what I want to ask is, among these, right? If there exists, how would you do that? Because each value is 10 to the 5th. You're not going to just go 10 to the 5th. I want to find the earliest, right? I want to find, like, given this, I want to find the earliest one that is true. How would you do that? Find the earliest one. I mean, if I am true, then I am the earliest one, right? Yeah, if I can make the jump to the end, then I'm the earliest one. And the next one can look here. Well, look to the earliest one. And if it is, then I become the earliest one. If not, no. Yeah, I think I only need to go as the earliest, the smallest one that can make it. Right, because the smallest step you do is 1. It doesn't really matter. Okay, let's give this a shot. Let's give this a shot. All right. Call it earliest. Get this up. Earliest will be n. Okay. I in range n minus 1, minus 1, minus 1. And at the end, we just want to see if earliest is 0. Okay. All right. Then we say if I plus nums I, right? That's the earliest I can reach. Oh, the last one doesn't really matter. My bad. Going on minus 2. All right. So yeah, this is plus this is the, if this is larger or equal to earliest, the earliest equals n, equals I, right? Else, then we don't make any change, because it just means I cannot get to the earliest. Like if I go all of those, I still cannot reach the earliest. Then it means I cannot get to the end. If I cannot get to the end, the earliest is still the original earliest. Right, so we go this and then we draw a turn. Earliest shall equal to 0. That's true. That's a false. Let's run some test cases for this. Yeah, so 100. 1 to 100. Ooh. I don't like it. This is more like it. Oh, and some other test cases. For example, a single value. Yeah, what if it's 0? Oh, like, yes, 0 is fine. Okay, not too bad. This is like, how many times I've done this? First time in 2019, that's 3 years ago. More than 3 years ago. And 2021, and then 2022. Let's check what type of method we used last time. DP, we record the earliest position from nums I plus 1 to n minus 1. All right. Call the earlier position that can reach the end. Thus, at nums I, all we need to check is whether I plus nums I can reach the earliest position. Okay, that was the solution last time. Reach maximum. Oh, it's computer maximum reach. Yeah, I like this. I think it's it makes more sense to me. Okay, so that's that. We are what? 906. Okay, let's do this. 1, 2, 3, and 4. Maximum enemy that can be captured. You're given a 0 indexed integer array. Forts of length n, representing the positions of several forts. Forts I can be this, this, or this, where this represents there is no fort at the ith position. This means there is an enemy fort at the ith position. I means there indicates the fort at the ith position is in your command. So either we have no fort, or it's an enemy, or it's not enemy. Now you have decided to move your army from one of your forts in position I to an enemy position J, such that, okay, the army travels over enemy forts only. Wait, hold on. The army travels over enemy forts only. Formula if k, for all k, where in between forts k equals 0. Well, wait, hold on, what? So the army travels over enemy forts. So if it's not enemy, that cannot travel. While moving the army, all the enemy forts that come in the way are captured. Return the maximum number of enemy forts that can be captured in case it is impossible to move your army, or you do not have any. Wait, what? One of your forts. Oh, I see what it means. We'll move from this to this, this to this. How many? No, wait. 1 is under your command. -1 is no fort. 0 is enemy. So how many zeros are in between? But that doesn't make any sense. Oh, there's no fort. Huh? You have decided to move your army from one of your forts, so this is a 1, to an empty position J. So empty position is here. 0, 1, 2, 3 captures 2 enemy. Moving army from position 8. 0, 1, 2, 3, 4, 5, 6, 8 to position 3. Wait, hold on. 0, 1, 2, 3, 4, 5, 6, 7, 8. No, it's 8 to position this. Gets 4. Oh, why make it so complicated? Maximum of enemy forts that can be captured. Between one of your forts and an empty position. Oh, I see. Now I see. Now I see what it's trying to do. Okay. So in this case, there's only 1 because yeah, it cannot be captured. I need to have this and this. There's nothing in between. Okay, what do you think? Basically, we'll find ones, right? All the 1 position on all the -1 position. But what we can do is just go through from left to right. We find a 1, and then we find a -1, and then we can capture, right? And then if we find a 1, and we find another 1, and we find another 1, that's a good question. That probably is not okay, right? Actually, let me try this. What if I have, you know, actually this is not a good idea. Well, this will say here. What do you want to do? I want to see, hold on. Given this situation, okay? What's the answer? Is it 1? Because it says it has to. Yeah, so it doesn't count. So the only chance we have, so we just go from left to right. Every time we hit a 1, we have to update. Every time we hit -1, we hit a -1, we can compute. And then we hit a 1 again, then we can try to see if we have a -1 before. But if before, hold on, how can we make this? We have a 1, right? And then 0 we just skip. And then 1 comes in again. We can get out. 1 skip, 0 skip, 1 come in, 0 0 0, -1 comes in. A Q. I can do this with a Q. That'll be fun. Have we ever used a, shoot. Oh, that's fine. Little bit mistake. Little bit mistake. It's a Q. Okay. We want maximum, right? So 0. For F imports. If not deck, Q. If not deck, first of all, FF, okay, and then if not deck, we'll add it to it. If we need I, if deck, we don't even have to have a deck. I just need 1. I just have a pre, right? I can just have a pre is forts 0 and 0. Then for I, in range from 1 to lem forts, right? And we can just say if forts I, right? If forts I, then we say if forts I is equal to pre 0, then pre or equal to forts I and I, right? Else, that means forts I and pre is not the same. And then we can say res or equal to maximum res the I minus pre 1, right? So we have this and this, the 0, 1, 2, 3. 3 minus 0 is 3, so I have the -1. Right, -1. And then we also pop, which basically just means if this is not equal to, we'll do this. Once we do this, we'll always do this. And then we will return res. Oh. That is not right. How? Oh, it's a 0. If forts 0, else Can we even do that? Yeah, it's not. How about this? Hmm. You know what? You know what? If forts and if pre and there we go. That makes more sense. Oh, we didn't test. I knew it. I knew it. How? How we got this one wrong? Yeah, I show you go to this, right? Oh, God. My bad. Change the premise. Stupid mistake. Oh, some medium problems are harder than this one. Yeah, either one pass. It's just, it does say a lot of things. All right. You want to do this? Okay, we can. I want to finish like by half an hour, so 8 minutes. Let's see. You're given two strings, positive, negative, containing the words denoting positive and negative feedback, respectively. Note that no word is both positive and negative. Initially, every student has 0 points. Each positive word increase a point by 3, whereas negative would decrease by 1. You were given n feedback reports represented by 0 index array and a 0 index student ID, where student ID I represents the ID of the student who has received the feedback report I. The ID is unique. Given an integer k, return the top k students after ranking them in non-increasing order by their points. So it's decreasing. Okay. In case more than one student has the same, the one with the lower ID rank first. So both are positive. Okay. How long is the string? Feedback length. 100. I can use. Ooh. Wait, are all the reports the same format? No word is present in both, okay? And then report I consists of a lowercase English letter. And space. There is a single space between consecutive words. Length is 100. Student ID is this. All the value are unique. And they're like, oh. But negative feedback can be, yeah, this is just one. They have multiple words in the negative feedback. Words. Okay, we can, gosh. How would you do this? So these are unique. It didn't say about the report. It just says a sentence, right? We just need to find the words that's in here is also in there. How? I mean, did it say everything in positive? Yeah, that doesn't really matter. And we kind of think like build a try for this, build another try for this. And then we just go through each word to see if the word is in this. Oh, one positive and one negative feedback. Wait. What if I have two positive feedbacks? Is studious, brilliant, and smart. Is not smart. Should be two going first. 1, 2. Wait, what? Oh yeah, it is 1, 2. Because that's the first. Okay, how about change this? It should be 2, 1. You can stack. Alright. You know what? It's be more interesting to do this. Let's say not. And here we do not. That will be 1, 2. Yep. I mean, we don't have to do a try. It can just be a set. Just go through every single word, put in the set, and see how many times it occurs. Yeah, I'm going to do this because the size is 100, right? The report length is 100, and then we split it. So the total number that need to be compared is not that much. And after that, we compute a score, right? So we have the score and the student ID, and then we just need to find the top. We always sort them. Yeah, then we just sort them. I mean, that's all right. I think this will work. Basically, here is what we're doing. PF will need to equal the set of positive feedback. NF equals set of negative feedback. And then we say L is equal to this. And actually, maybe I can do better. I'm going to say for R report and I in zip report and student ID, right? Then what? Then we say for word in r.split, right? And then we say word in posit in PF. And I want to int this thing, okay? So positive shall be the sum of this. Ooh, let's split it once. Negative is a sum of int word negative feedback, right? For word in words. And then L is going to be this. L dot append 3 times positive minus negative. That's the score. It's not enough. We also need the ID. And L dot sort. Key is equal to lambda tuple. We're going to return tuple 0 minus, this is inverse, and then tuple 1 positive. Then we'll return integer k, so the top k for top in L k, top k. What I want is 1. That shall do. Gosh, too complicated, the test cases. I'll just do it here. Okay. I don't think we'll time out. I don't think we'll time out. We don't have to, we can just split each report and check the words one by one, because the total length of the string in report is only 100. Thus, splitting it at most, right, at most will give us 50 elements, right, which is not that much. We're going to call it ON. Well, ON M, number of words. Okay. Set for hast. Oh yeah, you can do this way. Minus score. Dude, why are you so smart in here? Minus score is good. Minus score is good. Negative score to facilitate sort. Then I just need to sort. I can actually do even better. Return I for this I in sorted L. How about that? Oh no. A lot of things wrong. Yeah. Okay. That shall be it. Yeah, I don't want to do another one. We just call it. Let's call it, and I'll see you guys tomorrow. Adios.